This video is a quick note on absolute convergence and conditional convergence of series. Okay, so the definition is as follows. So a series, some AK, is said to absolutely converge if you take the absolute value of the individual terms and then sum them up into a series, if this new series converges. So that's absolute convergence. However, if the sum of the absolute values diverges, but the original series converges, then the series is said to be conditionally convergent. Okay, so the idea behind absolute convergence comes from the following fact. So there's a theorem that says that if a series is absolutely convergent, then the original series converges also. So essentially, if you know information about a series when you take the absolute value of the terms, then you get information about the original series. However, if the series of absolute values diverges, then that doesn't give any information. So the original series may converge or diverge. So if the absolute value series diverges, you have to use the alternating series test to check for convergence of the original series. Okay, so let's discuss a couple examples of absolute convergence. So suppose I take the series sum k equals 1 to infinity minus 1 to k plus 1 over k squared. So here the given series is an alternating series, but let's check for absolute convergence. So if I take the absolute value of the terms, the series, so then the alternating part goes away, and the series just becomes 1 over k squared. But this is a series we're familiar with. This is a p series with p equals 2. And so it converges. So that means that this series is absolutely convergent. So the original series automatically converges. So in this case, we were able to find convergence of an alternating series by checking for absolute convergence instead of using the alternating series test. However, this sort of trick for absolute convergence doesn't always work. So sometimes the series will not be absolutely convergent. For example, if you take the alternating harmonic series, so again, let's check for absolute convergence. So the sum k equals 1 to infinity the absolute value of minus 1 to the k plus 1 over k. So again, the alternating part becomes positive. So sum k goes 1 to infinity of 1 over k. But this is the harmonic series, or a p series with p equals 1, which diverges. So this series is not absolutely convergent. However, it is conditionally convergent because we've already seen that this series, the alternating series, converges from the alternating series test. So we see one example where the series absolutely converges, so you don't have to use the alternating series test. However, in the second case, it is not absolutely convergent, so you still have to check whether the original series converges or not using the alternating series test.